So we continue with exercise here. Question number 4. First 3 questions we already discussed. Now what you want to prove in this question? A minus b is a factor of a raised to n minus b raised to n. So we need to prove, factor means multiple. So you need to prove that a raised to n minus b raised to n equals to a minus b into some constant m, where m is some constant. This is what you need to prove, remember. Okay, so we start with this and we'll try to get this. We can prove by PMI also, remember, but here we use binomial theorem. A raised to n minus b raised to n. Now this a will rewrite like this, minus b plus b, because I need a minus b, adding and subtracting b, the whole raised to n as it is, remember, minus b raised to n. A minus b plus b minus b raised to n. Now we just take this as a, this as b, and we expand by binomial theorem. So by binomial theorem here, nc0 into a minus b the whole raised to n, this, into b raised to 0, plus nc1 into a minus b whole raised to 1 less power into b raised to 1, plus, let's write one more term here, plus nc2 into a minus b whole square into b square, and so on. Let me write the last term here. What will be the last term here? ncn into b raised to n. This minus b raised to n is already there, remember. We are doing nothing with that. That is already there. I want to write the previous term also. What's the previous term? nc n minus 1. Here power of b will be 1 less, n minus 1, and the power of a minus b will be 1, remember. This is the last term. I wrote the previous term. Here power of a minus b is 0, so here power of a minus b has to be 1. You say it's n minus 1, this is here n minus 2 into b square, and so on. In the last term you have b raised to n. So what's the power of a minus b here? 0. So in the previous term, what's the power of a minus b? It's 1. B raised to n minus 1. And this last term as it is, remember. I did nothing with this last term. Okay. What is NCN? NCN is just 1. So this will be 1. So this b raised to n will get cancelled. Fine. And from all the remaining terms, if you observe all these remaining terms, this one and this one, what is common? A minus b you will find common. This will get cancelled with this. From all remaining terms you will find a minus b common. So what I'll get if I take a minus b common? So you'll get here nc0 a minus b raised to n minus 1 plus nc1 a minus b raised to n minus 2 into b, and so on. Second last term is ncn minus 1 into b raised to n minus 1. If you simplify, this will be always an integer. We don't want to simplify that, but in general I'm telling you. So a minus b into m. This would be some integer, remember. So what you have shown finally, a raised to n minus b raised to n equals to a minus b into m, remember. So therefore you can say that a minus b divides a raised to n minus b raised to n, or you can say that a minus b is a factor of this. So therefore you can say a minus b is a factor of a raised to n minus b raised to n, remember, and therefore proved. You just recall, such things. If you find a cube minus b cube, then one factor is a minus b, if you remember. The other factor is a square plus ab plus b square. So a minus b is there, which is a factor of a cube minus b cube. you write a square minus b square, you know a minus b into a plus b. So a minus b is a factor of a square minus b square. You write a raised to 4 minus b raised to 4. Again you will get here a minus b into some expression here, right? So this is always true. I repeat what I did here. Just instead of a, I wrote minus b plus b and then just expanding. In the last term here, NCN is 1, you know this. So this is b raised to n, that will get cancelled with this. Fine? And from all the remaining terms, from these terms, what is common? A minus b is common. You see, minimum you will find a minus b. So taking a minus b common, and this is some constant. And therefore you can say that a minus b into some constant. And therefore the conclusion is a minus b is a factor of a raised to n minus b raised to n. Now what about next two questions, 5th and 6th? Such questions we did earlier. Question number 5 and 6 are just similar to refer exercise 8.1. First exercise. You will see that question number 11 and 12 are just a copy of these two. Right. Just go through these two questions. Still 6th I'll do for you, at least beginning, but you just go through these two questions, you will realize. Okay, so let's try to do this here. It's a question of just binomial theorem, remember. Now just to make the little bit simple, we call this as x. So let's take root of a square minus 1 equals to x. So therefore here what we'll get? A square plus x the whole raised to 4 plus a square minus x the whole raised to 4. At the end we are going to place the value of x. Let's expand this. You know how to expand this. 4 say 0, a raised to a square raised to 4, 4c1, a squared the whole cube into x, plus 4c2, a squared the whole square into x square, 4c3, a square raised to 1, and here what we'll get? X cube the whole cube, last term 4c4, here your x cube raised to 4, plus, let's come to next, there you have instead of plus x minus x. So this term and this term would have sorry, here it should be just x cube, remember, not x cube the whole cube, and this is x raised to 4. I'm sorry, because it's just x. Now what about this? 4c0, a square raised to 4, 4c1, a square whole cube into minus x, remember. So this term and this term will get cancelled. You can see both are same. That's what you did in these two questions. 4c2, a squared the whole square into here minus x the whole square. So it will be plus now 4c3, a squared the whole raised to 1 into your minus x the whole cube. So this term and this term will get cancelled. Plus last term 4c4 minus x raised to 4. This will be even power. Now let's see which term will get cancelled. So all odd indices term. This with this one, remember. Then cube term with this cube term. Fine. You are left with 1, 2 and 3 even power terms. 1, 2 and 3, and you have the double of this, you can see. So my next step will be, I'll write twice. This is equals to twice. These terms are double, you can just see. This is 4 say 0. You have a raised to 8. Just check in the previous step. 4c2. You have a raised to 4 into x square. It's double, remember. And finally 4c4 x raised to 4. Question number 7. There we want the value of 0.99 the whole raised to 5 with the help of binomial theorem. So what I'll do first, I'll rewrite this as 1 minus 0.01 here. You know it is 0.9 whole raised to 5. Now we expand by binomial theorem. By binomial theorem, let's expand this. We just write first three terms. So your 5c 0 into 1 here plus 5c1 into here we have minus 0.01 raised to 1 5c2 into here minus 0.01 the whole square and so on, but we are asked for first three terms only, so we are expanding only for first three terms. Now the question is just simplify. What is 5c0? It is 1 into 1, so 1. What is 5c1? It's 5 into minus 0.01. What is 5c2? You know it is 5 into 4 into 3 factorial. That will get cancelled with denominator by 2. And here you have 0.01 the whole square. So it is plus, because of that square, 0 followed by 3 zeros and then 1. Now we just simplify. 1 minus 0.05 here plus, this is 10 into 0.0001. Fine. So let's add all this. So I'll get the 0.951. That's the value. Just add this, you will get exactly this much. In the next question, you are asked to find n. What is n? That's the question. Now, ratio of the fifth term, you are given this ratio of fifth term from beginning to the fifth term from ending equals to √6 by 1 in this expression. 4th root of 2 plus 1 upon 4th root of 3 the whole raised to n in this expansion. Okay. Now fifth term from the beginning, which is obvious, t5. Okay. And fifth term from ending, if you just want to understand, let's recall this. I'll just write the general binomial expansion. nc0 a raised to n. nc1 a raised to n minus 1 b raised to 1. nc2 a raised to n minus 2 b square. And so on. Let me write here last term. If I write last term here, that is ncn b raised to n. Let me write the second last term here. If I write the second last term, ncn minus 1. Here power of b will be n minus 1. Power increases n minus 1 and then. And what about the power of a? It will be just 1 because here it is 0. Fine. Now you observe, you see in the first term, here you have nc0, ncn, and here a raised to n, b raised to n. Let's observe the second term. From beginning and second term from ending. Now if you notice, you see, here you have nc1, here you have ncn minus 1. Fine. And powers get interchanged. You see here n minus 1 is the power of a, here it is the power of b. Here 1 is the power of b, here it is the power of a, remember. If you write the previous term, here it is nc2. I'm just writing previous term. Let me write here nc. What is the previous term? n minus 2. What about the power of a here? It will be 2. And what's the power of b? It will be n minus 2. N minus 2 plus 1, n minus 1 plus 1. So it is n, remember, increases. So look at this. Third term from ending and third term from the beginning. What happens here? NC2, here NCn minus 2. Here 2 is the power of a, here 2 is the power of b. Here power of b is n minus 1, here, this is n minus 2 and here it is n minus 2 for a. So that concept I'm using and I'm writing here like this. So therefore we have fifth term from the beginning, and let's write here fifth term from ending equals to root 6 by 1. Now what is T5? T5 you have prepared formula. What's the formula for T5? NC4 a raised to n minus 4 into b raised to 4. Fifth term from the beginning upon. Now how do you write from the ending? As I explained, you see, if you have second term from the beginning, then here 1, and second term from ending n minus 1. Second term, third term from the beginning, here 2. Third term from ending n minus 2. So what we'll get here? NC here n minus 4. Right? Just observe this. What about powers of a and b? Powers of a and b get interchanged. Here power of a will be 4 and power of b will be here n minus 4 equals to root 6 by 1. Now just recall these two symbols are equal. These and these are equal. So this will get cancelled, remember. Right? So you are left with a raised to n minus 4 into b raised to 4 upon a raised to 4 into b raised to n minus 4 equals to root 6 by 1. Which concept you have used? NC4 equals to NC n minus 4. Fine. Now what about this? I'll take this one in the numerator. So n minus 4. This will in the numerator. So minus 4 minus 8. This I'll take down. So b raised to n minus 4 minus 4. So n minus 8 equals to root 6. So therefore you can write a by b the whole raised to n minus 8 equals to 6 raised to half. Now what is a by b? You know, a is nothing but, look at that question. What is a? 2 raised to 1 by 4 upon. What is b here? b, you know, it is 3 raised to minus 1 by 4. Just see the data, see the given expression, you will realize you are already given that here a is nothing but 2 raised to plus 1 by 4, and b is nothing but 3 raised to minus 1 by 4. This is just given in the expression. I'll take this one in the numerator, so you'll get 2 raised to 1 by 4 into 3 raised to 1 by 4. The whole raised to n minus 8 equals to 6 raised to 1 by 2. So you have 2 into 3, 6 raised to 1 by 4 into n minus 8 is already there, equals to 6 raised to 1 by 2. Both the bases are same, so you can just compare the powers. So here n minus 8 by 4 equals to 1 by 2. So n minus 8 equals to 2, and therefore n equals to here 10. That's required value. Here in the solution, this is not important. This is just for your information. I've explained you that how to write the term from the beginning and ending. Right? Combination symbols are equal. You know, this is same as this. First and last are always equal. Second and second last are equal. This one and this one. Combination symbols are equal. And what about powers to a and b? Here you know you have b raised to 0. A raised to n, b raised to 0. Here a raised to 0, b raised to n. Here power of n minus 1, a is n minus 1. Here power of b is 1. You see power get interchanged. with that concept, we have just written this 2, remember. So NC4 is same as NCn minus 4. Why these two are equal? Because sum of these two is above number. You can just notice. Add these two, will get above number. Therefore, these two will get cancelled. And powers 2a and b will get interchanged. Here n minus 4 is power of a. Here it's power of b. Here power of b is 4. Here power of a is 4. And then just we have simplified. Fine. Now, let's see the next question here. Question number 9. The 9th question, you are given this expression 1 plus x by 2 minus 2 by x the whole raised to 4. And we want to expand this. This is a question with the help of binomial theorem. Now this is actually a trinomial expression. There are 3 terms in this expression. So what we do, we consider just one is one term, this is one term, this is second term, and we'll use the binomial theorem. So your 4c0, this is a, remember this is b. So here, what's the first term? You know it will be a raised to n. So 1 plus x by 2 the whole raised to 4 plus 4c1, this is a, remember. So 1 plus x by 2 the whole cube into minus 2 by x the whole raised to 1 plus, let's continue, 4c2, 1 plus x by 2, you have squared here, minus 2 by x, here it will be squared, 4c3 into 1 plus x by 2, power will decrease, 1 here, minus 2 by x the whole cube. And finally last term, 4c4, that's 1 Here this term will have 0 power, so I'm not writing, minus 2 by x the whole raised to 4. Fine. Now you cannot live like this, you need to simplify. We need to in turn expand this by binomial theorem. These you can do directly, whole cube, whole square, and then you need to simplify. What's 4c0? I'll be writing on the next page now. So here this is equals to 4c0, 1. And simultaneously I'll expand this. Okay, let me write in this step this one as it is, the whole raised to 4. What is 4c1? It is 4. I'll keep this one as it is, 1 plus x by 2 the whole cube as it is, into minus 2 by x. What is 4c2? Just recall, 4c2, if you remember, it is 6. 4c2 into 1 plus x by 2 the whole square into, let me write here, whole square, so 4 by x square. 4c3, what's 4c3? It's same as 4c1, which is 4. 1 plus x by 2 as it is, and this is nothing but minus 8 by x cube. And finally the last term, which is 4c4, 1, 2 raised to 4, 16 upon x raised to 4. Fine. Now one more time, you need to use here binomial theorem. You can do here directly because it's a whole cube. You can do directly here. You just need to open the bracket. So I'm doing here 4c0, this one remember, into 1 plus 4c1 into x by 2 plus 4c2 into x by 2 the whole square plus 4c3 into x by 2 the whole cube plus 4c4 into x by 2 the whole raised to 4. This is just from, remember, first one only, from this one only. 4c0, 4c1, 4c2, 4c3, 4c4. Now we are at this place. Plus, here I'll do just like a plus b whole cube. So a cube plus 3 times a square b. So 1 a square into b plus 3 times ab squared. So 1 as it is and b squared, x square by 4. I repeat, a cube plus 3 times a square b plus 3 times ab square plus b cube, that is x cube by 8 into minus 2 by x as it is, remember here, plus, now what about this, 6 4s are 24 by x square as it is. We expand this, 1 plus 2 times ab, that is x by 2, plus the last term which is x square by 4. 4 into 6, 24 by x square already written here. What about this? Here 8 4s are 32 with minus sign. So minus 32 by x cube into 1 plus x by 2 as it is. 8 4s are 32 with minus sign by x cube, 1 plus x, plus here 16 by x raised to 4. Here remember, this one is expansion of the first one, plus starts from here, plus this is, I'm sorry, I forgot to write this 4 probably. So 4 into this, I need to put 4 here. 4 is already there. This is just expansion of that whole cube. Minus 2 by x. 6 4s are 24 by x squared. This is expansion of this one. 8 4s are 32 with minus sign. This one as it is and this one. Now again you need to put all these values and you need to simplify. So that I leave it to you. Remember, how do we express this? Remember, in power of x. Right. You start with like highest power of x will be 4, x raised to 4, and lowest power is 1 upon x raised to 4. Remember. So this is the first term, and then you just need to simplify. If I do one more step, let me do 4c 0. You know it is just 1. What is 4c4? 4c1, it is 4 into x by 2, remember. Plus, what is 4c2? That is nothing but 6 into x square by 4. What is 4c3? Same as 4c1, which is just 4. X cube by 8. What is 4c1? It's just 1. And this is x raised to 4 by, here 16. Here, this is minus 8 by x, remember. So minus 4 into 2, 8 by x into 1. So minus 8 by x. What about this? Here, just have a look at this. Minus 8 into 3. So minus 24. This x will get cancelled. Upon 2 is there, remember. So I'll just write minus 12. I repeat. 3 into 4, 12. 12 into minus 2, minus 24 by 2. So it is just 12. X will get cancelled. Fine. This minus is now with this. Minus. This 4 will get cancelled. This is minus 6. 1x squared will get 1x out of this x square will get cancelled. So just x. I repeat. If I take 4 inside, 4 will goes away. 3 into 2, 6 with minus sign. Out of x square, 1x will goes away with this. So you have this. Minus. What about this? This is 8. That 8 will get cancelled with this. 4 into 2, 8. That 8 will get cancelled with this. Out of x cube, 1x will get cancelled. So you are just left with x square. I'll come to this now. Plus, this will continue with plus, remember. 24 by x square. 2 will get cancelled. What about this? Plus 24 by x cube. 24 by x cube. Plus, what about this? Here 6. Just 6. 24 by 4, 6, x square will get cancel. Minus, this is 32 by x cube. Minus, what is this? This is 16 by x square. This is 16 by x square. And finally plus 16 upon x raised to 4. So here there is a little correction. This is, I suppose, if I take 24 inside this, 24 by x square here, 24 by this is just x, remember here it should be x, and in the last term here x square is will get cancelled, 24 by 4, so it's 6, just x, that's only modification. Now we are just going to combine these terms. So one is x raised to 4 upon x raised to 4, so that's the only term, 16 by x raised to 4. What about x cube? Only this term, so minus 32 by x cube. What about upon x square? Upon x square, one term is this. Is there any other term? Yes, one more is this. So from this you will get the plus 8 by x square. Fine. Then upon x term. What about upon x term here? You have 24 by x and minus this one. So it would be how much? 24 minus 8, it would be 16 by x. Then constant term. 6 here, 1, 7. 7 minus 12. So you have minus 5 here. Then next term about x. There are how many terms about x? This is, you see, this is 2x and this is minus 6x, so minus 4x. What about x square? This is 3 by 2x square and half minus x square, so it will be half x square. 3 by 2 minus 1, so I are left with half x square. This is half x cube, and this is nothing but x raised to 4 by 16. So this is the final expansion. Right? I just did it for you. You can also do, remember. It's not difficult. I understand it's a little bit time consuming, but you can spare some more time and try to do yourselves. The only important step there is you need to consider this as a one term. You can take these two also as a one term and you can use the binomial theorem, remember. Choice is yours, remember, whichever you do. Now, what about the next question? The next question is probably same question. You want to expand this one again by binomial theorem. So in the 10th question you have 3x squared minus 2ax plus 3a squared the whole cube. Right. So we do the same procedure. We take 2 as 1. I'll take this as one term a and this as b, and I'll expand by binomial theorem. So 3c0 3x squared minus 2x the whole cube plus 3c1 into 3x squared minus 2x the whole square b into 3a squared plus 3c2 3x squared minus 2x the whole raised to 1 into, now you have 3x whole square, and finally 3c3, the power of this one will be 0, 3a squared the whole cube. Now again, you know this is just one, you expand whichever you do it, but there will be 4 terms here, remember. 3c1, you know 3 here, you expand this 3a square I'll write in the beginning. So there will be 3 terms here. If you expand, whole square is there. What is 3c2? 3c2 is same as 3c1, and which is 3. This is nothing but the 9a raised to 4. 3 square a raised to 4 into 3x square minus 2x as it is. You need to open this at the end, plus 3c3 is just 1. 3 raised to 3, 27 into a raised to 6. Expand this and open all this and just check the backside answer. Right? That's what, like the previous question, you need to do. So you'll get the final expression. Fine.